All right, I think this is going to be my last example for today. Tomorrow I will finish up 4.5 for you and kind of field any questions that you are having. I would definitely say before I get started, for sure you can start your homework. I think basically after I do this slide, you could pretty much do most of it, but I would say probably a good idea to get close to like number 40 or so, at least to give yourself kind of a good head start. Okay. All right. So this takes us back to section 2.4, which talks about the squeeze theorem a little bit. Okay. And it says it can be used to evaluate a trig function pretty easily, especially sine and cosine, because they set up that natural smallest, middle, largest function, which we talked about, like baby bear, mama bear, papa bear. Okay. But it wants you to know that this theorem is also valid for limits at infinity. Okay. I think it's probably no surprise to you that the limit as x goes to infinity of sine x will not exist, right? There is no horizontal asymptote in this graph, right? Sine x oscillates between -1 and 1 forever. And so it is never going to settle down. It has no horizontal asymptotes. And so I think that makes sense that it doesn't exist. However, as soon as we get into something like this, sine x over x, what's going on? All right. So one thing that we know about sine x, and this is that setup for the squeeze theorem, is that we know sine x is always going to go between 1 and -1. We just talked about that, right? So if I'm interested not in sine x, if I'm not interested in sine x, right, but I'm interested in sine x over x, then I can go through and just divide all of these by x, right, and then their relationships should still be true. So the squeeze theorem says that if you take the limit of the smaller function, right, this is a limit we know because it's 1 divided by something really, really big, which is really, really small, and we take the limit of the larger function, in this case 1 over x, which again, we know that's going to be a number divided by something really, really big, which is 0. If these two limits agree, then the squeeze theorem says that function that's in the middle, okay, in this case, the limit as x goes to infinity of sine x over x must also be the same, right? And so it's pretty easy to prove that the squeeze theorem actually works, okay? If you are not so confident, I would encourage you to graph on your calculator this function, okay, this function, and this function, and kind of see the further out you get to the right-hand side of the graph, right, the closer and closer that they are getting together. My hope is that you feel real confident in this answer and this answer, and so it makes sense to you that the middle one also has to equal 0. Okay? All right, you guys, I hope you have a great day. Work on your homework if you're finishing this up early, and I will see you tomorrow. Happy Halloween!